Hi, I'm Paul Kilgan from GK Tuition, and in this video I want to talk to you about trigonometry. Now the question I've chosen to go through here is 2016 Paper 2 Question 8. In this question we're told that the height of the water in a port can be represented by the function h of t is equal to 1.6 plus 1.5 cos pi over 6 times t, where h of t represents the height of the water in the port in meters and t represents the number of hours since the last high tide. And we're told that everything is measured in radians here. So it mentions radians means the first thing you do is you have your calculator in radians for the whole question. Now we don't actually need it in radians for the first part here, but there's no harm. If it mentions radians, I'd have it in radians for the entire question. So part A here, it asks me to find the period and the range. Now you should know a formula to find your period. In one of these trig graphs, the period is given as 2 pi divided by c, where c is the coefficient of t. Okay, or in other words, c is the number in front of your variable here. So in this case, my coefficient in front of t is pi over 6, which means that in this case, my period is 2 pi divided by pi over 6. 2 pi divided by pi over 6, if you plug that into your calculator, you're going to get 12. And it's taken, t is measured in hours, so it's 12 hours. So I know that high tide occurs every 12 hours. Or in other words, that the tide replicates itself every 12 hours. Now the second thing I need to find is the range. In order to find the range, well, I'm told my baseline is 1.6. And my amplitude is whatever the number in front of my trigonometry is. So my amplitude here is 1.5 meters. That means if I start off at 1.6, in order to find the maximum height, it would be where I start off plus 1.5. So I know the maximum height reached by this graph is 3.1 meters. The minimum will be my baseline where I start off minus my amplitude, which is 1.5. So 1.6 minus 1.5, I know that the minimum height in this port is 0.1 meters. So I know the minimum is 0.1 meters and the maximum is 3.1 meters. So my range in this case, I can say my h of t is between 3.1 and 0.1. So the range in this case should be written like that. So that's my period and my range. For part B in this question, now, to be honest, we've already answered in part A, so I'm unsure why they've asked you this again. But in part A, I said the range was between 0.1 meters and 3.1 meters, so clearly the maximum height reached. My answer to part B is just 3.1 meters. In part C of this question, we're asked to find the rate at which the height of the water is changing when t is equal to 2. So straight away, you should recognize when a question asks you to find the rate, that means the derivative. If this function describes the height of the water, to find the rate at which the height of the water is changing, we need to get the derivative of this function. The derivative of 1.6 is just 0, so I just need to differentiate this term. Okay, now the fact that there's a 1.5 in front of it won't actually affect the question. I can just stick the 1.5 in front. But I need to get the derivative of cos pi over 6 times t. According to my log tables, the derivative of cos of an angle is just minus sine of that angle. So let's start off with that. The derivative of cos pi over 6 times t, first thing I want to do is minus sine pi over 6 times t. However, in the log tables, this is just an x. This is just a variable alone. But if I'm getting the derivative of cos of an angle where there's a number, where there's something more complicated in my fraction, I do exactly what it says in the log tables, and then I multiply by the derivative of the angle. So I've done exactly what it says in the log tables, and now I'm going to multiply by the derivative of pi over 6 times t. Simplify this one down. If I asked you to get the derivative of 3x, it's very straightforward. The derivative of 3x is just 3. Or in other words, it's just whatever the coefficient of my variable was, whatever the number in front of my x was. So the derivative of pi over 6 times t is just whatever's in front of the t, which in this case, the derivative of pi over 6 times t is just pi over 6. So that's it. So I get the derivative of cos of an angle just becomes minus sine of that angle. Then I multiply by the derivative of my angle. Now, if I want to simplify this one further, pi over 6 times minus 1.5 is minus 1.5 pi over 6 times sine pi over 6 times t. So that's as much as I can simplify it. And now I have a function that describes the rate at which the height of the water is changing. But I was asked to find that when t is equal to 2. So that just means everywhere there's a t, I'm going to sub in a 2. So it's minus 1.5 pi divided by 6 times the sine of pi over 6 times 2. I'm just going to plug all of that into my calculator. And if I do that, this works out as minus 0.68, and that's meters per hour. So the rate at which the height is changing relative to time, so it's meters per hour. Now, the next part of the question, it asks me to explain what that means in the context of the question. So first of all, we have to figure out what does t equals 2 mean. T equals 2 means that it's 2 hours since high tide. Remember, at the start of the question, it told me that t represents the time since high tide. So if t equals 2, that means that it's 2 hours after high tide. So 2 hours after high tide. Now the rate at which the height is changing is negative, which means that clearly the tide must be going out. If the level of water is decreasing, the tide is going out. So 2 hours after high tide, the tide is going out. The tide is going out. And the figure itself, the 0.68, tells me the rate or the speed with which it's going out. So the tide is going out at a rate of 0.68 meters per hour. So, and that is that's as far as I can explain it. So if you can conclude your question like this, it makes it very obvious to the examiner. You know exactly what t equals 2 means, you know exactly what the negative means, you know exactly what the 0.68 means. Okay, so in part D of this question, we're asked to use the function to construct a table and a diagram to represent the behavior of the water in the port over a 24-hour period. Now, first of all, we're told that high tide occurred at midnight. So we start off at midnight where t is equal to 0. And then we can just fill it in every 3 hours. So clearly every 3 hours we just go from 0 to 24. And if we sub into our function, sub into the original function we were given at the start of the question, making sure your calculator is in radians, you should get each of these values. So when you sub in t equals 3, you should get 1.6. When you sub in t equals 18, you should get 0.1, and so on. So I filled in my table here, and then I've drawn my graph. Now obviously your graph will hopefully be a little bit more accurate because you've got a scale. But basically your graph should look something like this. My maximum is 3.1, my minimum is 0.1. My midline here is along 1.6, so my midline is along there. You don't actually need to draw in a midline in this case, but your graph should look more or less like that. And it should be perfectly symmetrical. The important thing here is make sure you don't use a ruler to do this, because this is a curve. If it was a line, then you'd use a ruler, but if it looks like you've used a ruler, whoever's correct in your exam can take marks away. Because this is a curve, it has to be done by hand as opposed to using a ruler. So with this in mind now, part E becomes very straightforward. In part E, we're asked to use the graph to find the range of values, or find the difference between low tide and high tide. So clearly high tide occurs at 3.1 meters and low tide occurs at 0.1 meters. But because the question says use the graph, it's really important that you do actually use the graph. So what I would do is, you don't need to mark anything in for the height because it's on my y-axis. But for my minimum height, you should mark in maybe just a broken line going from this point to 0.1. So I could say the range of values is 3.1, which is my maximum, which is up here, minus 0.1, which is my minimum. So the difference between low tide and high tide in this case works out as 3 meters. So that's my part E. We can also now use this graph to answer part. For the final part of this question, we're told that a barge is coming into the port and that it requires a minimum of 2 meters when it's fully loaded. But once it's been unloaded, it requires a minimum of 1.5 meters. And we're asked, what is the maximum amount of time for which the barge can remain in the port. So clearly, if it requires a minimum of 2 meters, it wants to come into port as the tide is coming in. Okay, so in part F of this question, we're told that a barge is coming into port, and that when it's fully loaded, it requires a minimum of 2 meters. And once all of its goods have been unloaded, it requires a minimum of 1.5 meters. So we want to find what is the maximum amount of time that the barge can remain in port before it touches the bottom of the seabed. So in this case, clearly it wants to enter the port as the tide is coming in. So if you look at your previous graph from part D, realistically it wants to enter the port here. It wants to enter the port. That's going to maximize the amount of time it's going to have. So if you just go from your 2 meters and you draw a horizontal line across and see where does it intersect. Okay, so in an ideal world, the barge will enter at exactly this moment in time. And it will have to leave before the water level goes down to 1.5 meters. So we should draw another horizontal line here to 1.5 meters. So the maximum amount of time it can spend is between here. It'll go up to the maximum and then come back down, and then by this time it has to leave again. So in order to work out what's the maximum amount of time it can spend in the port, I just want to find what are the corresponding times that are relevant to this height. So at 2 meters, if I go across and then draw a broken line down, if your graph is perfectly accurate, it should intersect here at 9:30. It should intersect at 9:30 a.m. And again, same thing here, horizontal line across and draw a graph down. And once again, if your graph is perfectly accurate, it should be 15 hours and 15 minutes. So that means that it could enter at 9:30 and it would have to be gone by 15:15 or 3:15. So in this case, the maximum amount of time will just be 15:15 minus 9:30. So 3:15 minus 9:30, you have to work out what's the length of time between the two. Well, if I add on 30 minutes to this, that would bring me to 10 o'clock. 30 minutes and then another 5 hours would bring me to 3 o'clock. So that's 5 hours and 30 minutes. Then another 15 minutes. That means the maximum amount of time they could have is 5 hours and 45 minutes. So the maximum amount of time I could have is 5 hours and 45 minutes without hitting the seabed. So again, I hope this video made sense. If there's anything at all that you're unsure of there, then let me know in class during the week and I'll try and clarify it for you.